Guys, in this video, we will discuss about the bivariate variable or the several variable. So first of all, we have to know that what is the definition of a several variable. Suppose we consider here three variables u, x and y are so related that for every pair of values where x is defined over the region a to b and y is defined over the region c to d, then we can get that u has a finite single value. Then u is said to be a function of two variables, that is two independent variables x and y, and that is denoted by u is equal to f of x comma y. So from here we can say that u is the dependent variable and xy is the independent variable, and this relation contains three variables, that is more than one variable, that is known as the several variables. So now the question is that we know that how to find the limit of a single variable, but now the question is that how can we find the limit of a bivariate, that means whether the function contains two variables. So let us see that how can we find the limit of a bivariate function. See here, this is the definition of limit. That is, a function f of xy is said to be tend to the limit L, where L is a finite number that may be 0 or not equal to 0, as x tends to a and y tends to b, and symbolically we can write it limit x tends to a, y tends to b, as f of xy is equal to L. Or we can write it that a function f of xy in region R is said to tend to the limit L as x tends to a and y tends to b if and only if corresponding to a positive number epsilon there exists another positive number delta such that mod of f of xy minus L less than epsilon for open disk 0 less than x minus a whole square plus y minus b whole square less than delta square for every pair point x comma y belongs to R. This is the definition of the limit for a bivariate function. But now the question is that how can we find the limit? So now let us see that how can we find the limit. So see here I write some rules, that working rule to find the limit of bivariate data. That is, find the value of f of xy along x tends to a and y tends to b, and find the value of f of xy along y tends to b and x tends to a. And the conclusion is that if the values of f of xy in the previous steps remain same, then the limit exists, otherwise not. And here one thing remind here that a and b, the points a and b are not equal to 0. So what is the rule? That find the value of f of xy along x tends to a and y tends to b, and also vice versa, that is find the value of f of xy along y tends to b and x tends to a. And if the values of f of xy in these two steps remain same, then the limit exists, otherwise not. So now let us see one problem about this statement. See here we choose one problem that limit x tends to 1 to and y tends to 2, x square plus 2y by x plus y square. So first of all, by the method we have to find that what I write here, that find x tends to a and y tends to b, and also y tends to b and x tends to a. So we can do first anything. So first we find limit x tends to 1, and first we find limit y tends to 2, x square plus 2y by x plus y square. So if we put y equal to 2, we get limit x tends to 1, x square plus 4 by x plus 4. And now if we put x tends to 1, we get 1. We denote it by f1. Similarly, now we have to find a limit x tends to 1 and y tends to 2. So what we get? X square plus 2y by x plus y square. So here first we find limit x tends to 1, that is limit y tends to 2 into limit x tends to 1, x square plus 2y by x plus y square. So here we get limit y tends to 2, 1 plus 2y by 1 plus y square. And if we put y tends to 2 here, we get 1 plus 4 by 1 plus 4, that is 1. So, and we get 1, and we reminded the value is f2. And see here f1 is equal to f2, so we can say that the limit, that both the value of f of xy is same, so the limit exists. So the limit exists. Suppose if I between f1 and f2, if anyone is different from another, then we can say that limit doesn't exist. So now there is a question, and since we can use this condition when the points a and b are not tends to 0 by the definition. Now the question is that when if a tends to 0 and b tends to 0, then what we have to do? Actually, if a tends to 0 and b tends to 0, we have to find the limit along the straight line y is equal to mx and along a polynomial curve y is equal to mx to the power n. And if the value of this limit doesn't contain m, then we can say limit exists, and if it contains m, then limit doesn't exist because m is a real number. So now let us see that how can we find that this that when the points a and b tends to 0. So here first we have to put x equal to 0 and y is equal to 0. Then we have to find the value of f1. Then we have to find first y is equal to 0 and then x is equal to 0. Then find the value of f2. And if f1 not equal to f2, then limit doesn't exist. And if the limit exists, that means f1 is equal to f2. Then we have to put y is equal to mx, and then we have to find the limit f3. And then in that case, if f1 is equal to f2 not equal to f3, then limit doesn't exist. And if f1 is equal to f2 is equal to f3, then we can say the limit exists. And in that case, again we have to put the polynomial curve y is equal to mx to the power n, and we have to find the limit f4. And if f1, f2, f3 not equal to f4, then limit doesn't exist. And if f1 is equal to f2 is equal to f3 is equal to f4, then the limit exists. So you have to follow this procedure to find the limit of a bivariate function when the points a and b are tends to 0. So now let us explain one problem about this. So see here we consider one problem that limit x tends to 0, y tends to 0, x square y x to the power 4 plus y square. So this is very similar, that limit x tends to 0, limit y tends to 0. We find it first, f1 x square y by x to the power 4 plus y square. If we put y is equal to 0, this is 0. f1, so we get the value of f1 is 0. Now check limit x tends to 0, y tends to 0. First find x tends to 0. So if we put limit y tends to 0, limit x tends to 0, x square y by x to the power 4 plus y square, we get 0. This is the value of f2. So f1 is equal to f2. So now by the condition we have to now find that if f1 is equal to f2, then we have to put y is equal to mx. So now here we put y is equal to mx in the given function. So if we put y is equal to mx, we get x, limit x tends to 0, x square into mx by x to the power 4 plus m square x square. So what we get? Limit mx cube by if we take common x square, we get m square plus x square, and here we get mx by m square plus x square. So here we get 0 is equal to f3. So now we can say that f1 is equal to f3 is equal to f3. So now we have to find the f4, and along the line y is along the curve y is equal to mx to the power n. So if we put y is equal to mx square, so what we get from here, that we get mx to the power 4 by x to the power 4 plus m square x to the power 4, and we get after simplification m by 1 plus m square, and where we can find the different values of limit for different values of m. So we can say different values of m. So we can say that f1 is equal to f2 is equal to f3 not equal to f4. So the limiting value of this function doesn't exist. So I hope you understand. So thank you.